Okay, so in this video, I'm going to talk about how we describe distributions. So before I explain how to do it, I'd like you to brainstorm a little bit about what are some of the ways we can describe these two distributions. So I'm referring to this picture. So we've got this distribution in the red, and then this distribution here in the blue. So take a minute, pause the video, and talk about a couple ways you can describe these. Use your prior knowledge. Okay, so for us to remember describing distributions, we're going to use this nifty acronym, SOCS. So don't forget your socks, especially in the winter, you'll be cold. So the first thing that this means in SOCS is the shape. So we don't deal a lot with modality in this course, but in future statistics courses, you'll hear about this. So the ways we talk about modality is we literally just look at our distribution and we see how many peaks it has. So you can see here, it's unimodal because there's only one peak here. This is bimodal because there's two peaks. And then multimodal is what we would refer to anything that has more than two peaks or valleys. So if you go back to the previous slide, you would say that those were both unimodal. So that's just an example of that. The other way that we describe shape is that we talk about skewness. So we've already mentioned this in class a few times. So in statistics, we generally either have a left skew or a right skew. Otherwise, it's symmetric. So symmetric would be, it pretty much is the same on both sides. So again, the first ones we saw on this page, we would say, okay, that one's symmetric because if I folded it in half, it'd match up. This blue one's symmetric too. If I folded it in half, it would match up. That's pretty easy to see there. But sometimes we have skew. So I think it's easier to remember this negative or positive skew just because of the context. So I'm going to look at the left skew first. So when we have left skew, it's a little counterintuitive, but let's talk it through. A left skew means we have a lot more data points on this end. We have a lot more data points on the positive end, but it trails off to the left. The mean is then higher than the median because we've got just a few points over here that are so low, it is pulling our average down. Our median's still in the center of the data, but our mean's actually lower because we've got some values over here, some data points that are pretty far from the rest of ours. So it gives it a left skew. It's a negative skew because we're being pulled to the left by these really low numbers. In the same regard is right skewed or positive skew. We've got many data points here on our left-hand side, and it trails off to the right because we've got a lot of positive values, a few big positive values that pull our mean above our median. So the median is not influenced by these points that don't really match up or we might be surprised by. The median isn't influenced by these points that are extremely high or extremely low, but our skew is. So this is an important concept that we're actually going to come back to again. So I would probably make a note in your wherever you take notes on how you want to remember that. The way I personally remember it is right skewed is when I have a lot of values here on the left. It's a little counterintuitive. And then I think left skewed has a lot of values on the right and it's being pulled. But the positive and negative helps because negatively skewed means we've got lower negative values potentially pulling our data down, whereas positively skewed, we've got some unusual positive values above the rest of our data points. So that's the first way we describe distributions. The next part of SOCS is outliers. So outliers happen in a lot of different ways. We'll see later on box plots
the TTC printer was off, so it didn't go, which...
Does that mean you have to resend it?
We should print to the office one so that it prints nicely anyway. So.
Does the TTC not print nicely?
The print, the ink's out.
Oh, right.
So that's obviously somebody's turning it off because it won't even print now because the ink's so low. So
who is in charge of doing the ink?
No, that's it. Dennis Murphy's the one that we just ordered some.
Oh, whoops. It's been recording. My silence. Whoops. Okay. So visually, there's a few ways that we're going to see outliers. So on a box plot, they either appear as this solid dot, and that's just an outlier, or they're this asterisk, which we won't dive into so much in this class, but this is an extreme outlier. And then on a graph over here, so this is our X and Y, you can see, so we've got most of our data is around here, and then this dot literally lies out far away from all of our other data. So in another video, we're going to discuss how to more formally find that using some math and the interquartile range, but for now, we'll just move on to how to describe distributions. So the next part of SOCS is the C, it's center. So we've discussed already in our class the 3 ways to measure center. So I'm not going to go through these as in-depth as that intro to univariate analysis, but the first one is mean. So our mean, we are going to use the sum. This symbol here is sigma, and all that means is we sum our x values and divide by how many there are, and we did some practice in that. So the only difference between this and the population mean is that this capital N represents our population, and you can read that below. Our next measure of center was our median. So the median was literally the middle number if our data was in order. And then our mode was the number that occurs the most. So the most occurring number. And you'll recall sometimes we might have more than one mode. Sometimes we might not have a mode if everything just appears once. So there's infinitely many ways we might see that. And lastly, the way we describe a distribution is spread. So with regards to spread, we've already talked a little bit about it, is the standard deviation. And the standard deviation is related to our variance. So our standard deviation and our variance, they're ways that we talk about how spread out our data is, how on average each data point is from the mean. So just a quick visual, which we're going to talk about this in class, and I'll make another video on how to calculate it, but generally we'll use technology. So a distribution like this versus one like this. We can pretty clearly see that this is more spread out, this is less spread out. So we would expect our standard deviation in the one above to be higher than our standard deviation in the one below.